Quiz 3 solutions. We're asked to find f prime of a, and I think you do it two ways, using the definition of the derivative and the difference quotient. All right, the definition of the derivative says that f prime of a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. And as long as I'm here, that difference quotient says that f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. Alright, so now that we have those two handy, we can start working on the problem. You find f prime of a, well here's f of x, so what we got is f prime of a is equal to the limit as x approaches a of f of x, which is 1 over x, minus f of a, which is 1 over a, divided by x minus a. And hopefully this looks like a limit that we evaluated. I think we had this on the last quiz, maybe with numbers in here. The way you evaluate this is you try to make all the x's equal to a's, but that doesn't work. It gives you 0 over 0. So you do some algebra. Specifically, you get a common denominator up on the top, and you think of the bottom as x minus a over 1, so that we can say this is a minus x over x times a divided by x minus a over 1. And now that we have this all as a fraction divided by a fraction, the way you divide fractions is like multiplying fractions, except you multiply by the reciprocal. And just because I know where I want to end up, I'm going to do one more little trick here. And instead of writing a minus x, I'm going to write negative x minus a. And that will be helpful because now this x minus a and this x minus a can cancel each other out. And what I'm left with is that this derivative is the limit as x approaches a of negative 1 divided by a times x. The limit as x approaches a of negative 1 over a times x is, change all the x's into an a, get negative 1 over a squared, which is our final answer. Alright, hopefully we can get that same answer using the difference quotient. Let's see, using the difference quotient, f prime of a is the limit as h approaches 0 of f of a plus h, so 1 divided by a plus h, minus f of a, 1 over a, divided by h. Okay, same idea. We need a common denominator up top, so what we'll do is we'll multiply this times a and this times a. We'll multiply this times a plus h and this times a plus h. And what that will give us is a minus a plus h divided by a times a plus h, all divided by h, which I can write as times 1 over h. Alright, a minus all this mess is just negative h times a minus a plus h is a minus a goes away, negative h is what I'm left with. And then on the bottom here, I guess I can just leave it like that, a times a plus h. Now what happens is this h and this h cancel each other out. So what I'm left with is this is equal to the limit as h approaches 0 of negative 1 divided by a times a plus h. But as h goes to 0, this is just a plus 0, or a. So I got negative 1 over a times a. That is negative 1 over a squared, which matches up with what I got up there. Nice. Alright, 3 curves, 1, 2, and 3. We're supposed to label them as g of x, g prime of x, and g double prime of x. And explain our logic. Okay, let's see. I guess what I would notice is, let's first look at curve 2 here. Note that right here at this point, curve 2 has a derivative of 0, right? The slope of the tangent line at this point is 0. But the height of curve 3 and the height of curve 1 are both not 0. In other words, curve 3 and curve 1, neither curve 3 nor curve 1 are the derivative of curve 2. So maybe I'll put a little arrow here and say because curve 3 has slope 0 at this point, but neither curve 1 nor curve 2, wrong name, because curve 2 has slope 0 at this point, but neither curve 1 nor curve 3 have height 0 at this point. Neither 1, maybe I should do Roman numerals here, nor 3 is the derivative of 2. So what does that tell us? Well, if nothing is the derivative of 2, 2 must be this guy right here, right? Because if 2 were this guy, then something would be its derivative. If 2 were this guy, something would be its derivative. So g double prime of x is curve 2. And once you get one of them, the rest of the logic isn't too hard. Now what we can do is be like, okay, this curve right here, curve 2, which curve is that the derivative of? So if you look at this point right here and this point right here, this is when curve 2 has height 0. So at these points, curve 2 has height 0. But what I want you to notice is curve 3 has slope 0. Right? The slope right here is 0 and the slope right here is 0. And curve 3 has slope 0. So curve 2 is the derivative of curve 3. Well, you already told me that curve 2 was g double prime of x. So if curve 2 is the derivative of curve 3, g prime of x must equal curve 3. And so by process of elimination, we get that g of x is equal to curve 1. And you can kind of check your answer now that you have them all. Okay, curve 1 here, this blue guy, let's see, its slope should be given by curve 3. And it looks like it is, right? This guy's flat right here, the slope is 0. This guy's going up here, this guy's positive. So you can go through and check all your answers, but you should come up with these answers in similar logic. And if so, that's the end of this quiz.